Are you intrigued to understand what those scribbles on the whiteboard on the thumbnail mean? Then keep watching to find out. Welcome back to Scotty's Clock World. I upload new clock repair videos on Sunday and Wednesday mornings of every week. Third wheel out. Now we'll put the escape wheel in. We'll have to drop it in under here. Never easy to do without bending teeth, but there we go. Drop it up into the top. I'll hold that up a tiny bit while I align it down at the bottom there. And get some posts aligned. Okay, we're out down the bottom. So pull that in with our pivot locator. That is just about there. Down a tiny bit. Got him. Right, so line that post. And that'll drop in. Okay, that'll give us a good reading. Now, we look at that pivot there on the top. Yep, all over the place. And then at the back, that pivot there. Not too bad. But they will all have to be replaced, because if you're replacing one on the front plate, you replace the one on the back plate also at the same time, because even if it's not too bad, it's not going to be long before you need to do it. Right, now a little bit of theory on what we're doing and why we're doing it. This is a hole that's been drilled into one of the plates. That's the plate top and bottom there, as we have running across there. Alright, that's the pivot that's running through the hole, the arbor, the wheel and the other end of it. Now when all this is functioning properly and the pivot is being oiled, there's a very fine molecular layer of oil all the way around the pivot. So in actual fact the pivot is not touching metal to metal on the plate. It's supported by the thin layer of oil. And while that layer of oil is there, there's very little friction and very little wear on the pivot or on the bushing. Now as time progresses, the oil collects dust and dirt and dries out and gets harder and eventually forms a grinding compound and starts to grind into the steel of the pivot and the brass of the plate. So this is why every 3 years you should have your clock checked out and re-oiled, because oiled properly, the oil in this little oil sink up here that runs over and covers the pivot will last about 3 years. Now, if you don't have your clock serviced and it runs for years and years and years without being serviced, then the oil will capture dirt and solidify, causing expensive damage to the movement. Now in our next diagram, this is the same as the above. For example, the back plate of the clock movement. But over the years, the grinding compound has gradually worn away part of the pivot and part of the bushing. So instead of the pivot running true equally between both sides of the hole, it starts to run off at an angle. And the oil continues to act as a grinding compound and continues to cause problems with wear. Now this is an exaggerated version of course, but so you can see what I'm talking about. The pivot is now actually touching metal to metal up here and metal to metal down there as it falls from running correctly to running at an angle. And this is where you get those wear lines in pivot. You see from time to time a pivot will look like so, and it'll have a little groove cut in it up one end like so. This situation here produces that. Also, there is dramatically increased friction between the metal-to-metal contact there and the metal-to-metal contact there. And if this is not cleaned up and repaired, then it's going to get worse and worse, and it won't take too long before it will stop your clock. Because the big killer of mechanical clocks is friction. You want to reduce the friction as much as possible. Now, the last thing we'll look at, we'll draw this as all its teeth on the outside. That's a barrel mainspring. And let's say it unwinds in that direction. So the first wheel, which will sit here, will turn in the opposite direction, that way down there. And the lantern pinion will obviously also turn in the same direction. But the second wheel here, which is driven by the lantern pinion, turns in the opposite direction. And the power of the spring is forcing through all the way up here. And by the time it gets to the second wheel, which we've got here, and it turning that way, the plate coming down there and down there to hold the pivot, the force from the spring is trying to push that pivot, that wheel, over to the left in the direction of its turning. And that's the reason. Let's do another one of the plates, like so, and then we'll look at it side on. That's the plate there, and it has a hole in it like so, and the pivot sits in there. And as the third wheel is pushing this way with the strength of the mainspring in pushing in that direction, this is why when you see worn pivots, they tend to wear down this way down here. That's the direction, because the force of the mainspring is turning them in that direction. So what we're looking for, we're looking to make sure, draw our plate again, and there's our circle. We're looking to check and make sure that that circle is not very much out of round. It can be a tiny bit out of round, and that's not a problem. But if it starts to get a piece worn out down the bottom here, you've then got an additional problem to solve before you start pushing the movement. Now we'll draw the hole, that's the top of the bushing, and then down the bottom it runs like that, for example, and that's your normal round bushing, and that's a pivot in the center. Now if you just align your bushing machine or your cutter or your broach where that is there, what happens is the sides of the cutter will rest around there like so, dropping down into that bottom piece down there. So if you just use your cutter there, then you will cut a hole like so, but in actual fact it should be up there and coming down around there. But what you've done is you've lowered where you put the bushing, and the pivot will not be level as we were looking at this diagram up here. It won't sit like that and run evenly. The hole you make is not going to be correct. So how you solve that problem, we'll get our little diagram again, but that's where it goes, and it's now down like so. This is a bit that's been worn out. There's the center of the original bushing hole where the pivot should go. So to alleviate this problem up here, what we do is we use a rat tail file normally, because they're quite small, and we duplicate that piece up here on the top. We've now got that piece we cut out, that piece is worn out, and it's approximately the same. Now when we drop the cutter into that, whether it's handheld in a pin vise or on a bushing machine, it'll hold into the center and it will touch these pieces down here, the sides down here, and it will in actual fact cut a round hole around there like so. If you find this video helpful, please leave a like and don't forget to subscribe. And the hole will be in the center where it's supposed to be, and it won't be higher and it won't be lower. And it feels a bit strange actually cutting this out with a rat tail file, because you're making the hole far worse. But it's the only way to get that center again so that it runs around there. You'll find that you'll have to put a bigger bushing in it, of course, to take up the extra space, but that's how you return the pivot to the center where it belongs.